Earlier I asked you to make for me the largest rectangle that you could
Can we copy this?
a single length of a pipe. Now it's more important that you write. And I got a whole variety of them, right? We got these skinny ones that look like more like squares maybe. And we got this guy. Who actually did this?
I did that.
Of course.
Here's the problem, year 11. And I would feel the same way in the sense that when I gave you those equations before, it felt like we just kind of plucked them out of nowhere, right? It felt like we almost just made them up, okay? In some cases they do. But I'm going to show you that in some cases they don't make them up. They actually have to think hard about how to derive or come up with them. Let's look at this very simple problem. Let's look at the problem where we have a single length of y and we want to maximize the area of the rectangle that we can create with it. Okay? The first step is, I like to always draw a diagram. I'm a very visual person. I think most people are quite visual. I like to draw a diagram of what's actually happening. Okay? That's step one. Now why does that help me? This in itself doesn't help me. But I want to introduce variables.
X and Y.
X or Y.
Those are the sides.
They're the ones that we're most used to seeing, and well done, Callum. You can see that X and Y, we could let them be the length of our two sides. You know, so far, nothing too complex. But this simple representation is going to be really powerful in helping us understand the situation. I've done this, I've drawn a diagram, I've introduced variables. Here's the hard part. I want to form an equation if I'm not given one. And you haven't been given one in this case. You've just been told the situation. It's very clear what I'm trying to do. You tried to do it yourselves. How can I form an equation involving these? And think back to when I looked at the equations before with the profit and the depth of the pool.
Y equals?
Yeah, you had like y equals to something, right? Y equals to some expression.
But it's rectangles, you're gonna have to go the same
Yeah.
equation with a rectangle.
Yeah.
So it'd be x squared.
No?
Yeah, so how can I just kind of form an equation out of
2x.
just two variables?
Well, you're finding the area, so it has to be area equals to something.
Let me write that down. Let me write down what features of a rectangle that I know. As Natasha said, I know that the area is equal to length times breadth. Okay. Do I know anything else about this particular rectangle?
20 centimeters altogether.
Ah,
Perimeter
so
equals
the
20
perimeter, well done. The perimeter is equal to 20.
What year 4 you're in?
That looks wrong.
But,
Right,
20 centimeters, I guess.
You
But, remember, I don't want to just say that perimeter is equal to 20. I want to introduce my variables. I want my equation to involve variables. How can I introduce these x and y variables into my perimeter?
Or factors of 20, or say.
If you just do 20 equals x times y.
Yeah.
5 times 4.
like 4x times.
Yeah, Natasha?
Would be 2x plus 2y equals
Think about what perimeter is. Perimeter is the distance around the shape. What are these lengths?
2x.
2x and 2y.
And as Natasha said, you can write that as
Oh, you've got to be joking.
2x plus 2y. Is that what you said, Dylan?
I did say it.
Oh, sorry, I didn't hear you, mate.
No,
I'll give you
No,
credit.
he did say 2x.
No, he did.
He did.
I heard it.
No, you did.
But now we have these two equations. Year 11.
So x and y equal 5.
How do we bring them together?
Oh,
Factorizing.
factorizing?
No.
And here's what you want to do. To bring them together, you want to think about what am I actually trying to maximize?
Area.
The area. Find the maximum area of the rectangle. Okay, the perimeter is fixed. The perimeter has to be 20. Okay, no matter what kind of shape I have, I'm limited to a
That's
20
not a
centimeter.
variable.
Sorry?
Those two aren't variables.
20 is a
These two are
variable.
variables, yeah.
But not the perimeter.
20 is
The
a
perimeter
control
is
variable.
fixed, yes. So, when you think about this, right, when you have your y, okay, in this sense, we're not going to have y there.
Oh, you have 20.
I'm trying to form an equation where I have an expression, and then why do I take the derivative? Because I want to maximize whatever that expression is. Before in the company one, it was the profit. In the pool one, what was I trying to maximize?
Volume.
The volume. So I had V, or I had P. What am I trying to maximize here?
A.
The area. I should have an expression for A, and I want to maximize it so I can find an expression for A dash. So right now, my area is equal to xy. Okay? But when you take your derivatives, right, you can only have one variable on the other side. Okay? Usually you have y equals to something with x's inside. In this case, you can't have x and y's both in there when you're trying to take the derivative. So I need to think a bit differently. I want to see if I can get rid of one of them.
But A.
Now I want to keep the A, because the A is what I'm trying to maximize. I need to find A dash ultimate.
Get rid of the x.
Yeah, I want to try to get rid of one of these x and y variables. And I would think, can I write one in terms of the other? Well, if I come back to this equation, let me just rewrite this a bit differently. 2x plus 2y is equal to 20. Can I get y expressed as something else? Can I get y expressed in terms of x? And I could.
But then it has to be squared.
You have to set it.
Well, let's just move it over to the other side. I've got 2y is equal to 20 minus x. How can I get y by itself?
What happened?
Divide both sides by 2.
What happened to the 2x? What happened to your 2x?
Yeah, what did happen to my 2x?
Oh, that confused me.
Yeah, me too. I was like,
I just went with it.
crazy.
I divide both sides by 2, what do I get?
Boom, gone.
So
10
10 minus... Sorry about that. Why do I want this? Well, okay, when I'm trying to take the derivative, I really only want one variable in there. And that's what I've done here. I can express y not just as y. Y is also the same as 10 minus x. So, in this case, my a is now x multiplied by what? It's not just x times y.
Oh, it's x times 10 minus
X
x.
times 10 minus x. Now
We
we
know
know
how to
how...
form an equation.
Yes, and that is step 3. Take this and you think about what information you're given. You know that x and y are the lengths of your rectangle, and you know that the area can be found by multiplying those lengths, and the perimeter can be found by summing those values together. And now you have this expression here. And to take the derivative of this, you've got two expressions multiplied by each other. An easier way, again, is to just expand them, right? 10x minus x squared. It's getting exciting.
Whoa, dude.
I found it, it's about 5.
I'm just giving you a heads up for what we're looking for, right? We know this is a parabola, we know it's concave down, but remember, we want to, once we form the equation, we want to find the mass and min.
So, you haven't found
stationary
A
point.
dash.
Why do you have the X in front of the brackets
Where's that?
in the area?
Because
here?
A equals A.
So over here I replaced y with 10 minus
Oh,
x.
okay.
Yeah, just to show you multiplying by the whole thing.
Yeah.
So now we want to
Yeah, boy.
find that first derivative. So I've got a dash is equal to 10 minus 2x, good. What do I want to do next?
You sub in.
Let it be.
You always let it equal 0.
Let a dash equal to 0 for stationary points.
It equals 5.
Flat points.
Sure does that.
So then I've got 10 minus 2x is equal to 0. 10 equals to 2x. What's x equal to?
Right.
I don't believe you. How do I know that's the maximum?
You need a
Well,
table.
20.
Table.
I don't believe you.
That
Sorry,
kinda makes
every
sense.
time year 11, you need to be testing them. Yes.
So that kind of makes sense. So if it's 4 sides,
Yeah.
20 centimeters, like 20 divided by 4.
Keep going, let's keep going.
So if you use,
I want you, use the table second derivative. I'm going to use the table method
if you
here.
use second derivative, you'd get just x equals to nothing.
To a positive number. No, you get a negative number.
Yeah, X equals negative.
Oh, sorry, I was thinking that x equals 5.
In fact, that's probably easier. Why don't we do it that way? Alright, a double dash
See, I'm full of
equal
bad
to
ideas.
negative 2.
So why did you tell me to not write this down when everyone's writing it
So
down?
concave down. Oh, I didn't want you to write down the question, but yeah.
The second derivative is so much
Let's keep
easier.
going. Yeah, it depends. It's situational. It's situational.
And then it's a maximum.
Yeah, so since it's concave down, therefore x equals to 5 is a maximum.
Can we do another one?
We sure can.
No.
Because I need to write
We
one
need to
down.
find out which sides we should use.
Ah, yes. So,
Curious.
right,
I want to
Fine,
know
sorry, I
who's
should
the
have brought
best
that up.
rectangle.
x, y,
Curious.
2x plus 2y equals to 20. So find the maximum area of the rectangle. What I didn't write down was find the dimensions. Why don't we do that? When x equals to 5, I already know x is going to equal to 5. What's these other values going to be? Well, I can just check, right? I want to look for y now. I want to look for what the length of y would be. I'll just replace x with 5 in my equation. 2 times 5 plus 2y equals to 20.
10, and then you get 10 to the other side, so 10, so 2y, x equals 5. Y equals 5.
20. Wait, what?
Yeah, y equals
2y
1.
is equal to 10.
Y equals 1.
Y is equal to...
That's what I said, y equals to 5.
Oh,
which
my-
is the same thing. Wait, what?
Wait, 10 over No, 20 over 10.
What is happening?
That's
Everyone's
really
confusing me.
Wait a minute.
Wait, are we
So-
finding
Oh
the
no,
minimum
it's 20
now?
minus 10.
Yeah, no, so I already found when x equals to 5
That's
is
a
when
square.
when I have a maximum, and what are the dimensions of the other ones? Well, you can find the other length because you have this equation that represents the perimeter.
That's a
2x plus
square.
2y is equal to 20. When x is equal to 5, that's when my maximum area occurs. We found that y is equal to.
But that's
Oh,
square.
it's a square though.
But what did you say before earlier?
It's always going to be 20.
No matter what you do, it's going to be 7.
Which
About a square. When someone mentioned a square.
Oh, I can't remember. They're the
Because a
same thing.
rectangle is a rectangle.
Yeah, but no matter what, it's still gonna be the same
Square
area.
is a rectangle.
A square is a type of rectangle. So this question here, when I bend this into a
Still got.
rectangle, I can use a square because a square is
It's a
just a
rectangle.
type of rectangle. So there's nothing wrong with that. Okay,
Is
nothing
there,
wrong
I
with
swear it's still gonna be the same area all the time, no matter what.
that. Well, this is what? What's the area of this one?
That's what I said.
Area is
Like,
equal
you
to
make a
what?
circle.
25.
25. Let's try another. Give me
it's
another.
gonna
Give
be-
me another dimension that I could use.
6
Oh,
and 4.
actually, it's actually not. Don't worry.
6, 4. What's that?
24.
24. Okay.
Ah.
At this point here, you've maximized the area within this. It's not by much. It's only by 1
That
square
doesn't make
centimeter.
sense because you kind of just made one side longer than the other side short.
It's weird, right? Because think about a really, really thin. Think about like a really, really thin rectangle. I don't even know if I could do it.
Like 1 by 9.
Yeah, like that. That doesn't have much area
That's better
compared
than
to
5 by 5.
one of the
Nathan has to add up to 20.
one of these
don't we?
ones here, right?
True.
Does that make sense?